Hi everybody. Today we're going to talk about trace tables. Trace tables are a way to figure out what an algorithm is doing or what a piece of code is doing by keeping track of the values of the variables as you step through the program. So we start by creating our table itself. We have three variables, x, y, and a, and we're going to track their value. So the first thing we do is we see that up here we're going to assign values of 200, 10, and 0 to start. Then the next thing that happens is we drop into the loop. So we say while x is greater than y. Well, 200 is greater than 10. So we go into the loop and we say x equals x divided by 2. So x becomes 100. Y equals y times 2, so y becomes 20. And a equals a plus 1, so a becomes 1. We're at the bottom of the loops. We go back up and we check, well, 100 is still greater than 20. So we go into the loop again. X equals x divided by 2, so 100 divided by 2 is 50. Y equals y times 2, so that becomes 40. A equals a plus 1, so that becomes 2. And we go back to the top of the loop. 50 is still greater than 40, so we go into the loop again. And we say x equals x divided by 2, so that's 50 divided by 2 is 25. Y equals y times 2, 40 times 2 is 80. A equals a plus 1, 2 plus 1 is 3. And then we go back to the top of the loop. 25 is not greater than 80, so the loop stops, and we're going to display x, y, and a, so we're going to display 25, 80, and 3. And that's basically all a trace table is. So let's look at one more example here. Let's say we have some code that says a equals 7 and b equals 1. And we're going to say while put the semicolons there to suppress the output, while a is greater than 0, we're going to say b equals b times a, and a equals a minus 1, and then end, and then we're going to display b. So we make our trace table. We have a and b. Now, why don't you try pausing the video and completing the trace table yourself, and then once you're done, unpause, and we will complete it here on the video. You can see whether you got it right. Okay, so we start. We have a equals 7, b equals 1. We get to the while 7 is greater than 0, so we say b equals b times a. 1 times 7 is 7, and a equals a minus 1, so a becomes 6. We go to the top of the loop. 6 is still greater than 0, so b equals 7 times 6, which is 42, and a equals a minus 1, so 6 minus 1 is 5. 5 is still greater than 0, so we go again. b equals 42 times 5, which is 210. And 5 minus 1 is 4. 4 is still greater than 0, so we again look at the and we drop into the loop, and 210 times 4 is 840, and a drops to 3. 3 is still greater than 0, so we say b equals 3 times 840, which is 2520, and a becomes 2. And then 2 is still greater than 0, so we drop into the loop again. B equals b times a. 2520 times 2 is 5040. A becomes 1. 1 is still greater than 0, so we drop in the loop again. 5040 times 1 is still 5040. And 1 minus 1 is 0. Now, 0 is not greater than 0, so the loop stops, and we display 5040. Well, this algorithm really then is taking 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's the factorial algorithm. And the ending value is 5040. And using a trace table lets you figure out what is going on.